So we just went through a couple of minutes of why the pump was so important. We said it pulls mobile phase from the top of the machine into the sample, mixes it with the sample, and then allows it to be injected on the machine and continues to push the sample and the mobile phase through the machine out of the other end. So the pump is a very important major player when it concerns HPLC analysis. And again, we said that out of the pump, which is what you're seeing here on the screen, this silver piece is the actual pump itself, and then we take the pump and we just maintain it over a course of time to make sure that it's doing what it needs to do. The rest of the tubing we're not really going to be concerned with. All of that is extra stuff that we can kind of bypass because we only need to know an overall view of what this machine is doing for us. Now, the pump is going to create a variable for me. And this variable is something that I want to kind of key in and keep in mind as I do my analysis throughout this project or throughout the experiment that I'm getting ready to do. And this is a very important value. Without this value, I am not able to do anything at all. I need this number. Now, what is this number? This number is called flow rate. Okay, so imagine you have a column with stationary phase on the inside, and I have injected sample up here at the top. Okay, well, my mobile phase is going to come through and begin to push this sample through the column. But this is a variable that I need to control. The mobile phase going into the column and being pushed through the column. I have to make sure that this stays consistent. I want it typically the same from beginning to end. I don't want to change my flow rate up unless I absolutely have to. So bottom line, I have to control the flow rate. And the pump allows me to control the flow rate. The typical flow rate is provided in milliliters per minute. So for example, one of the labs that I might do in an experiment on a daily basis is running something at a half mil a minute, 0.5 milliliters for every minute that the machine is on. This is typically the standard flow rate that I often see, and I don't really see anything below 0.5. It's kind of the cutoff value, but at the same time, it's also the widely used number that's out there for the most part. A half mil a minute. Well, I can change this number up. In the software, in the computer, I can tell it, well, I want you to pump now 1 mil a minute instead of half mil a minute. And that's okay for the machine. You just give it the orders and it changes the pump, and the pump begins to pump a little bit faster, and then all of a sudden everything is okay on the computer screen and I don't really have to worry about too much of anything else. So it's a very simple value for me to key in. And then in those modules, when we talk about the software, we'll go through the software screens and I'll show you where this half mil a minute or 1 mil a minute or 0.75 mils a minute or 0.6 mils a minute will be keyed in. The thing that you have to keep in mind is that as you increase the flow rate, you are making things speed up through the instrument quicker. If things go through the instrument quicker, you're going to get some resistance, and this will increase your pressure of the machine as well. Higher flow rates, higher pressures. That's just the way that it is. Does it double? Is there a direct relationship between the two values? And the answer is no. On our instrument with Shimatsu, a flow rate of about 0.5 will give us about 500 psi as far as pressure goes. If we jack that up to 1 mil a minute, our pressure then goes to about 1300 psi. So this is something that I want to keep an eye on, because if the pressure gets built up too high, then the tubing inside of the machine begins to start popping loose. And I don't want to call a plumber to have them come out and plumb all of the tubing inside of the HPLC all over again, because I've been popping joints left and right. So this is something I always want to keep an eye on throughout the process. When you start looking for lab experiments, or maybe you already have a lab experiment, and you're looking at HPLC methods, you're often going to see a flow rate that's listed. The flow rate is a requirement. They have to report how fast that you have sent a sample, or they have sent a sample through the machine. And you are going to have to do this as well. So when you're in the laboratory and you're working with this equipment, there are certain things that you want to write down, and this is one of them for HPLC. You're wanting to write down flow rates that you are using the system on. So that is a requirement. That's something very special. You need to put that in a laboratory book. You need to put that into a laboratory report when you submit your data to someone. Very, very important value. And this can change depending on the user, depending on the method, and depending on what you're separating. So flow rate, extremely important. And it's coming from the pump. And the reason that it's important is because it controls the separation. Sometimes, if it goes too slow, you get bad separation. Things do not separate on you. And sometimes, if it's too fast, well, things just flood through the column all in one chunk, and you do not get any separation at all from those components. So that's something that you have to keep in mind, and that's something that you want to look at, and look at your chromatogram and look at the data that's coming off of the instrument to make sure that things are separating off the way that they're supposed to. And if they do not, well, maybe flow rate is the culprit, and you can go back and you can change that value and see how your components behave after you change the value. This is just like driving on the interstate. Sometimes you drive too fast, sometimes you drive too slow. If you drive too fast, you get a ticket. If you drive too slow, sometimes you get a ticket. So we want to make sure that our HPLC instrument does not get a ticket. We want to make sure that our HPLC is operating under an ideal speed limit. And as long as it is, then we should get some good separation that comes from the machine and from our samples. But if it's too slow or if it's too fast, we often see problems as far as the separation is concerned. So on the screen, again, flow rate very important, because flow rate is going to determine my pressure, and my pressure determines the separation, and flow rate is in the middle of all of that mess. So again, very, very important number for me to keep an eye out with. 1.5 is typically the highest value that we see. 0.5 is typically the lowest value that we see. That's what we call the working range most of the time with whatever experiment that I'm doing. Higher than 1.5 and lower than 0.5, you maybe could see some of that out there, but it's not used that often because we do see problems with the separation and as far as my components are eluding from each other. So that's the story with flow rate, and in the next video we'll take a look at the eyeballs of the instrument, and that is called the detector.